Sketching a quadratic curve. Probably the normal way of sketching a quadratic curve is to take out the calculator and use the table function. But here we've been asked to sketch it by finding the intercepts and the turning point. The y-intercept, we could read it off the standard form. It's 5. It's the constant term when the function is written in a standard form. So y-intercept is 5. The x-intercepts, we call these the roots. So if we let the function equal 0 and solve the equation, so if x squared plus 4x plus 5 equals 0, well, if we multiply across by -1, it should also be true that x squared minus 4x minus 5 equals 0. And we'd see the factors of this are x minus 5 and x plus 1, giving us roots x equals 5 and x equals -1. So this gives us another set of points, 5, 0 and -1, 0. It's also asking us to find the vertex. We could do this by writing the function in complete square form. I'm going to do that here. It might be easier, in fairness, to differentiate the function and let it equal to 0. And you see that -2x plus 4 equals 0 quickly enough, showing that the x is 2. And if you sub 2 back in to the function, it gives you 9. So 2, 9 is the answer. I'm going to complete the square though, so I'm looking at which complete square begins x squared minus 4x. And we see that's x minus 2 is the complete square. So I can rewrite x squared minus 4x as x minus 2 to be squared minus 4. So when I substitute that in for x squared minus 4x, we end up with the vertex form of the equation, which is that negative x minus 2 to be squared plus 9. And when would this have its maximum value? This is a negative quadratic, so it's a max rather than a minimum value it would have. It would be when x is equal to 2. And if x was equal to 2, well then with the vertex, the output of this will be 9. So 2, 9 is the vertex. But again, it may be differentiation is an easier way of doing that. But we have the points we're asked, so I've just put the points on the graph, and I suppose you would want to know beforehand that this is the shape of a quadratic, so you sketch the quadratic. Perhaps the real purpose of this question, though, is that within it we have the 3 different forms that a quadratic expression might take, and we have interesting information we can get from each of them. So we'll notice here we have the standard form, the factorized form, and the vertex form. And maybe this is important to know. So the standard form, we could read off that, that 5 is the y-intercept. The factorized form, we could read off that, where it crosses the x-axis. We could see the roots are 5 and -1. And in the vertex form, we could be able to read off that 2, 9 is where the turning point is. So it's maybe the important learning in this question is about these 3 forms of the quadratic expression.